In this video, we are going to solve question number 5 of exercise 1.1. The question is, use Euclid's division lemma to show that cube of any positive integer is either of the form 9m, 9m plus 1 or 9m plus 8. So we have to express the cube of any positive integer in either of these forms, either 9m or 9m plus 1 or 9m plus 8. Let's go through the solution. So here we'll assume a to be any positive integer for which the divisor b is equals to 3. And then by Euclid's division lemma, we can write it down as a is equals to 3 times of q plus r, where a is the dividend, 3 is our divisor, q is the quotient and r is the remainder. For some integer q which is greater than or equals to 0 and the possible values of remainder are 0, 1 and 2. Because r is greater than or equals to 0 and less than 3, which means remainder is greater than or equals to 0 and less than the divisor. So in the first case, we'll write down a is equals to 3q plus 0. Here we are taking remainder as 0. So a value will be equals to 3q. Now we'll take cube on both the sides. So we are going to get a cube is equals to 3q whole cube. So if we will multiply 3q thrice, we are going to get a cube is equals to 27q cube. So what are we doing? We are multiplying 3 times. 3 into 3 into 3, we are going to get 27 and q into q into q will get q cube. So it's easy to take 9 common from 27q cube. If we will do so, we are going to get a cube is equals to 9 times of 3q cube. So we can write down it in the form of 9 multiplied by something. Hence, our final step would be a cube is equals to 9 times of m. So clearly we observed that when remainder is equals to 0, we are able to write down the cube of positive integer a as 9 times of m. Now let's consider the rest two cases where remainder is equals to 1 and remainder is equals to 2. Now in the second case, we are taking remainder equals to 1. So we will be writing a is equals to 3q plus 1. If we will take cube on both the sides, it will be a cube is equals to 3q plus 1 whole cube. So how to evaluate this? We will be using the identity which says a plus b whole cube is equals to a cube plus 3a square b plus 3ab square plus b cube. So using this identity, we are going to expand 3q plus 1 whole cube, where if you will compare, a is nothing but 3q and b value we are going to take it as 1. So a cube can be written as 3q whole cube plus 3 times of 3q whole square multiplied by 1 plus 3 times of 3q into 1 whole square plus 1 whole cube. So if we will simplify this entire expression, we will get a cube is equals to 3q whole cube will become 27q cube. 3 into 3q whole square into 1 will give us 27q square, because 3q whole square will become 9q square. When 9q square will be multiplied with 3, we are going to get 27q square. Multiplied with 1 will lead us to again 27q square. Now 3 into 3q, 9q, and 9q into 1 whole square will again give us 9q only, plus 1 whole cube. So the cube of 1 will be again plus 1 only. Now finally, we are writing a cube equals to, from the first three terms, 27q cube plus 27q square plus 9q. We are going to take 9 common from all of them. Hence, we can write down 9 times of 3q cube plus 3q square plus q. And this plus 1, we are going to keep it as it is over here. So, it's easy to write down it in the form of 9 multiplied by something plus 1. So, finally, we will be writing a cube is equals to 9 times of m plus 1. So, easily in the second case, what did we observe? When we considered remainder is equals to 1, we got the cube of any positive integer as in the form of 9m plus 1. Now, let's consider the third case where remainder is equals to 2. So, in the third case, we will be writing a equals to 3q plus 2 where remainder is equals to 2. So, if we will take the cube on both the sides, we will be writing a cube is equals to, we will be writing a cube is equals to 3q plus 2 whole cube. Now, this how to expand it? Again, we will be using a plus b whole cube identity, which is a cube plus 3a square b plus 3ab square plus b cube. Now, here if we will compare a plus b whole cube with 3q plus 2 whole cube, wherever we will have a, we will be writing over there 3q, and wherever we are having b, we will be writing 2 in that place. Let's expand it. So, it would be a cube is equals to 3q whole cube plus 3 multiplied by 3q whole square multiplied with 2 plus 3 multiplied with 3q multiplied with 2 whole square plus 2 whole cube. So, simply we have used this identity in order to expand 3q plus 2 whole cube. Now, let's simplify it further. We can write down 3q whole cube as 27q cube. 3 into 3q whole square into 2 will give us 3 into 9q square into 2, which will be nothing but 54q square. 3 into 3q into 2 square will be written as 3 into 3q into 4, which is 36q, plus 2 whole cube will be written as 8. So, it is easy, if you will observe, to take 9 common from the first 3 terms. Let's take it common then. We will be writing a cube is equals to 9 times of 3q cube plus 6q square plus 4q. Plus this 8 will remain as it is over here. So, finally, we will be writing a cube is equals to 9 times of m plus 8. So, what did we observe in the third case? When we considered remainder equals to 2, we can write down the cube of any positive integer in the form of 9m plus 8. So, we observed all the 3 cases where if we are considering r is equals to 0, we were able to write down the cube of any positive integer in the form of 9m. In the second case, when we considered r value equals to 1, we were able to write down the cube of any positive integer in the form of 9m plus 1. And finally, in the third case, when we considered r value to be equals to 2, we were able to write down cube of any positive integer in the form of 9m plus 8. So, clearly, cube of 3q, 3q plus 1 and 3q plus 2 are of the form 9m or 9m plus 1 or 9m plus 8, where m is an integer. And hence, we can conclude that cube of any positive integer is either of the form 9m or 9m plus 1 or 9m plus 8. For some integer,